Okay, we're going to be talking about multiplying polynomials. And today we're talking about multiplying a binomial times a trinomial. And we're going to talk about meaning you're multiplying two terms times something with three terms. And today we're going to be talking about how we do that using the box method, just like we did using binomials. And I'll also show you double distribution. This bit.ly will take you to some Desmos graphs if you're interested on how to check your work using Desmos, but I will also demonstrate that for you here. So let's get started with some actual work. We have two terms here and three terms here, so we need a 2 by 3 box. The binomial is going to go on the side with 2 on it, and the trinomial is going to go on the side with 3. And just like we did before, we're just going to multiply everything in here. So 3b times 3b squared, 9b cubed. Negative 8 times 3b squared, negative 24b squared. 3b times 4b, 12b squared. Negative 8 times 4b, negative 32b. 3b times negative 2, negative 6b. And negative 8 times negative 2 is positive 16. We're just going to go through here and see if we see any like terms. Like terms are the same variable raised to the same power. I have a b cubed, so I have 9b cubed. Let's see if we see any other cubes. And I don't. So let's look for squared. Negative 24b squared plus 12b squared. Well, that's negative 12b squared. Next, I'm going to look for just b's. I have a negative 32b minus 6b, so negative 38b. And finally, one constant, positive 16 plus 16. So this should be our product. Let's check in Desmos. So I've put in the question, and down here we put in the answer that we found, the product. And we're going to add a slider. Set b something to something other than 1. Let's try 2, and these should evaluate to the same number, which they do. And if we want to do this checking using graphs, it's going to be the same thing, but we're going to change all the b's into x's. So I've changed my b's into x's. And what we are asking ourselves is, does the blue graph cover the red? And if it does, then they're the same. So we found the product properly. But I want to show you one other way to find the same solution, and that's called double distribution. It just means that we're distributing everything in here over everything in here. And we're going to distribute, since there are two terms, we have to distribute double, right? So we have 3b times 3b squared, 3b times 4b, and 3b times negative 2. So 9b cubed plus 12b squared minus 6b. And now we're going to distribute everything by negative, we're going to multiply everything by negative 8. So negative 8 times 3b squared, negative 24b squared. Negative 8 times 4b, negative 32b. And finally, negative 8 times negative 2 is positive 16. Just like we did before, we're going to look for like terms. I have 9b cubed. And now I'm going to look for b squareds. I have plus 12b squared minus 24b squared. That equals negative 12b squared. Now I'm going to look for b's. Negative 6b, negative 32b, negative 38b, and one constant plus 16. And so this is our product. The box just gives us another way to organize that information. Let's try one more. One more binomial times a trinomial. We're going to draw a 2 by 3 box. We have 2n plus 3 and 5n squared minus n minus 4. You're going to take all the operators with them. Okay? 2n times 5n squared, big times big, 10. Add the littles, n cubed. 3 times 5n squared, 15n squared. 2n times negative n. Well, there's a negative 1 out in front of here, so we have negative 2n squared. There's a 1 here and a 1 here. 3 times negative n, negative 3n. 2n times negative 4, negative 8n. And positive 3 times negative 4, negative 12. And you may start to see a pattern depending on how you've organized these. Just like we did with the binomials, you may start to see a pattern where you can combine like terms along the diagonal. So positive 15 minus 2n, positive 13n squared. Like terms along the diagonal here, negative 11n. Only one constant and only one cube term, so we have as our product 10n cubed plus 13n squared minus 11n minus 12. Let's check that using sliders and graphs on Desmos. We've typed in the question, we've typed in the product, we're going to add a slider, we're going to set the slider to something other than 1, and these should evaluate to the same number, and they do. And we can also check using graphs by changing the n's to x's. So when we graph these, the blue should cover the red, and it does. So we have found the product correctly. I hope this was helpful. Thanks for watching.